Our next talk is on getting started with supercomputing, um, and you're good to go.
Okay. Hi, everyone. My name is Jillian Lehosky. I am at PSC, Pittsburgh Supercomputing Center. We are a part of the Mellon College of Science at Carnegie Mellon. I am going to talk today a little bit about our flagship machine, Bridges 2, as well as the ACCESS program. Keep in mind when I say program, I mean project funded by the NSF. It's not a computational program, which is a project that allows all eligible researchers to get time on supercomputing clusters around the country for free. So to actually get started, let's talk about why you would even want to use a supercomputer. We're going to go pretty introductory for this. So using a supercomputer is really beneficial because much like Julia is a programming language designed to be optimized for scientific use, supercomputers are pretty much computers that are designed to be used in scientific research. Jobs are ran using a scheduler in queue. I was first introduced to supercomputing when I was working on a project studying quantum chaos. We were doing some linear programming, and it just took forever to run on my personal machine. It would get interrupted. I'd be running for 6 hours, and then I would have to do homework, and something would break. So I would send that code off to our local cluster, and it would run for the 8 hours, be all safe and protected, and then I could just get the results. You also can use multiple threads, which gives you faster performance. That's essentially when you take a big task and split it up into a separate subtasks that are all performed at the same time. That can really increase performance, and parallelization is actually native to Julia. If you're using a lot of other languages, you have to use different packages that can just be a really big hassle to figure out how to work, get them all optimized and working. We also have CPU and GPU options available, which are just faster. And additionally, we have a shared file space. It's just controlled using easy Linux file permissions. So if you're working in collaboration with people, it's really easy for them to just hop on your project and go to your directories when something is needed, because you don't have to send it back and forth. Actually using a supercomputer is sort of just controlling it from your own computer. You aren't actually, at our data center typing in it or anything. So you're going to connect via SSH to submit jobs from your own computer. Additionally, we have a platform called Open on Demand. This is a more sort of IDE GUI interface if you're more comfortable using interfaces like that. We also have Julia 1.5.2 pre-installed on Bridges 2, but there are options to do your own install. We have pretty good documentation for this in our Bridges 2 user guide that explains the steps really clearly, so you're able to do your own install for whatever version or packages you need. I have an example of what a script would look like for how you would actually run your job. So down at the bottom, you see that line, Julia threads, Slurm CPUs per task. Essentially what that's doing is running a parallel job of whatever script.jl says. You would have this file saved in your directory on the computer and then use a command like sbatch, run it. It would get sent to wait in line until it's able to run, and then your job would run and you would get notified when it was completed. So if you're interested in actually using a supercomputer, it seems a little bit daunting, and I'm sure you think it's expensive, but it's actually not because of ACCESS. So ACCESS is a program funded by the National Science Foundation that I work on. What it does is essentially gives all of the different supercomputing centers across the country money to build these supercomputers, with the caveat that we allow researchers on to use them for free. So the way this process works is you aren't actually applying to use Bridges 2 or Delta at NCSA or whichever resource you may decide to use. You're first going to apply for your allocation within ACCESS. You'll get awarded that, and then you exchange those ACCESS credits that you receive to get service units on a resource, and then you're able to run your research, do your jobs, and do your science. The biggest issue when running into, or that I run into with new users who are requesting an allocation, is this different project types we have. So the Explore project type gives you 400,000 access credits. All we need from that is an abstract and a PICV. If you submit your request for an Explore project after this, it'll probably be approved by the end of the day. And once you do your exchange, you can get on Bridges 2 in about 2 to 3 days. We also have the Discover and Accelerate options. Discover requires just a brief one-page main document telling us your goals as well as the resources you intend to use. And then Accelerate is a bit more extensive. We have a panel of outside reviewers do this, and graduate students are not eligible to be the leader of these projects. However, that is still an option. And then finally, we have our Maximize opportunities, which have 2 submission periods a year. We're in one right now. I expect the next one to open sometimes at the end of the year. Those are awarded only in service units. So You have to have a really good idea of what you want, what resources you're using, exact scaling of your code, and its performance. But that's something to consider if you expect to use a lot of computation. So who's actually eligible for this program? So graduate students can only be PI on Explore and Discover projects. We don't allow undergraduate or high school students to be PI on any projects, but a lot of these rules are pretty flexible, and we have a way to get you on no matter what. If you just ask us, we'll figure something out for you because we want you to be able to do your science. There's no citizenship or geographical requirement, but the PI must be associated with a US-based institution. So let's say you're a Nigerian citizen, you're a PhD student at CMU, but you're at home in Nigeria for the summer, but you plan to come back, you're still able to use an allocation as long as you're associated with that US-based institution. We only allow one allocation without a supporting grant, so you kind of get like a freebie at first where you don't need to have any outside support. And as long as that allocation is active, you have to have a supporting grant for another allocation. So that would be any sort of outside NSF grants, NIH, any grants from the college, in order to get that second allocation. We also do allow industry and nonprofit work. However, we do have the expectation that you will publish and share your results with the community because Access supports open science. And we want to make sure that there's nothing proprietary, that everything you do is being shared. To go back a bit to Bridges 2, these are the different partitions we have for you to run on. Up top, I have the exchange rates written. I know it's a lot of text, so I tried to bold everything that we care about. But up top, you can see the exchange rates. So 1 core hour is 1 access credit. So if you have an Explore allocation, that means you're able to have 400,000 core hours over the course of a year. We have 504 RM nodes, each have 64 cores, which to go back to the parallelization example, generally your personal machine only has about 8 cores on it, but as you can see here, we have a lot more than that. So you're able to parallelize your code a bit more. We also have the extreme memory, which is pretty similar to regular memory, but just with more RAM. And then we have our GPU partition. We recently got some H100 nodes, which have been very, very popular and very useful for a lot of people. So there's a lot to do with Bridges 2, and like I mentioned, there are also a lot of other supercomputers, high-performance computers across the country that you are able to use with Access. So as much as I love Bridges 2, there might be something that suits you a little bit better. And that's just about everything, a quick run-through of it. I have my email as well as the PSC email listed there. I'll be around if you have any questions. Let me know. Thank you.
Let's have a round of applause for the speaker, and we do have time for a couple questions. And can the next speaker start getting set up, please?
Thank you. My question is about Julia version 1.5.2. Seems a little old, but Julia does designate certain versions to be long-term support or LTS versions. Would you consider a policy to always support the LTS versions?
Yeah, for sure. I mean, we install our packages based on the demand is received because a lot of packages or software can be installed by the user using custom environments or different solutions. So for the ones that we have implemented, if we get enough requests for that, or if we just see a need for that, that's something that we definitely can look into for keeping that on the machine.
Time for one more question, I think. Okay.